Okay, cool. So section 1.1, properties of real numbers. So throughout the course, we'll be working with different kinds of number sets. Primarily be working with whole numbers, integers, rational numbers, and real numbers. And it should be, yeah, it should be right there in the middle. Yeah. Yeah, you got it. Yeah. So anyway, some of these sets will overlap with each other. For example, number 2 is a whole number, an integer, a rational number, and a real number. Before I get into all those different categories, let's have a quick overview of whole numbers. So whole numbers are just numbers that are whole. There's no decimal, there's no fraction. Actually, technically, these are decimals. How would you write 2 as a decimal? You'd say 2.0. 2.0. How'd you write 2 as a fraction? 2 over what? 1, exactly, right. So these actually are fractions too, technically, and decimals, but they're whole because we don't actually see anything coming after decimal. We don't see a fraction symbol, so we call whole numbers, right? Kind of like if you have a carton of eggs, how many eggs are in the carton? There could be none. There could be 1, 2, 3. There's not half an egg, or 3/4 of an egg, or a negative number of eggs, right? So it's just things you can count for the most part. Now integers, are integers larger than whole numbers? What do they include besides whole numbers? Are there negative numbers? Right? They're negative numbers also. So basically the whole numbers, but also they have negative integers, right? Do you need a pen or pencil or?
Yeah, I can write a pencil,
Sure.
sorry.
No worries, you're good. I got plenty here. Yeah, I'm glad there we go. Yeah, so those are integers, just so you know. So you just want to make sure you're cool with the terminology. Terminology is a big deal in algebra 2. Actually, I think sometimes we blur or don't really emphasize terminology in algebra 1. Did anyone have algebra 1 here with Mr. Donahoe? Yeah, he's really big on terminology, so hopefully you guys are cool with that. Geometry, we try to reinforce it, and definitely by this class, we just want to make sure it's not an issue. Rational numbers. Now, rational number is like the next level. So basically, you have whole numbers. Let me actually do this as like a Venn diagram, if that makes sense. Just trying to think here. So whole numbers are here. Integers are here. So the whole numbers are part of the integers, right? So you have the whole numbers a small circle. Instead of integers a bigger circle because it's more inclusive, right? The rational number is an even bigger circle. Because the rational numbers include integers and whole numbers, but what are really rational numbers? Really, you got to focus on the first 5 letters of ratio. What is a ratio, guys? When you hear the word ratio, what do you think? What's your name? Man, yeah, go, man, yeah. When you think of ratio, what do you think of? Like the ratio of something is like just like
1:1.
yeah, exactly. Or like let's say for example, you have like a jar of marbles and there's the ratio of red to blue is 2 to 3, right? So it's a fraction essentially. It's a fraction. But we said that whole numbers could be fractions too, right? Can't 2 just be 2 over 1? So rational numbers are any number that can be written as a fraction, where both top and bottom are integers. So like -4, for example. That's a fraction. -4 over 1. You got negative top and 1 down below. It's all good, right? Or make it -8 over 2. Same thing. But there could be decimals too, though, right? They totally could be decimals. Like you could, let me clear some space here. It's getting a little busy. Like 2.5. Guys, what's 2.5 as a fraction? That'd be what over what? If you want to write that as a fraction, what would be up top? Andrew, go ahead. I think you know. How about 0.5? What's 0.5 as a fraction? 1/2. Perfect. So what's 2 as a fraction? Like 4 over 2, right? So well, 5 over 2. 5 over 2, right? So any decimal, as long as it terminates or repeats itself, right? So that terminates, right? Because that ends, it doesn't go on forever. That could be run as a fraction. Heck, if I do 0.94, maybe this is not terribly obvious, but 94 over 100, because you have two digits after the decimal point. Or how about 0.3 repeating? Does anyone know what that is as a fraction? What's 0.3 repeating? 3. That'd be 1 over what, guys? 1/3, right? Yeah, there you go. So totally that works. So those are all rational numbers, repeating or terminating decimals, or just a ratio of two integers. Now, irrational, total opposite. Let me get rid of this here. So what I'm going to do is I'm going to make a rectangle. It's kind of its own little circle. Okay, it's its own little thing. Irrational numbers are not whole numbers. They're not integers. They're not rational, obviously, because you have the negative prefix IR. So not rational, right? So in this case, it can't be written as a ratio of two integers. It just can't. And it doesn't have any repetition and doesn't have any pattern. Never terminates. What are some examples? Pi, right? Pi just goes on forever. It's 3.14, I think 159, and that's the best I can do. I don't really care to memorize the digits of pi. Or root 2. Root 2 is a funky number, right? It's not a perfect square. So that's another example. And there's some other ones, but I think we'll just stick with those two for now. Those are all examples of irrational numbers. They can't be written as a ratio of two integers. Basically like square roots. Of non-perfect squares. Actually, why am I doing that? Like another example, you like root 5. But root 4 is 2, so that's rational. Lastly, real numbers. Real numbers is the most inclusive. All these are real numbers. Okay, so rational, irrational, doesn't matter. They're all real numbers. Now, the odd numbers are not real or imaginary. We will talk about that in Algebra 2. I don't know if we'll have that discussion in this class. If we get near the end, when we talk about quadratic equations, we could have that discussion. But what if you have like root -4? That's kind of weird, right? Does anyone know what that would be, actually? Has anyone learned about imaginary numbers? Maybe in another class or with a tutor? No? Okay. Don't worry about it. We'll cross that bridge if we get a chance. If not, we'll do an Algebra 2 in the fall or whenever we cover in CPM course. Okay. So I just did the Venn diagram for you guys. So it says make a Venn diagram. I just did it for you guys. That's it right there. There's a Venn diagram. So it's essentially because you have this overlapping, right? The real numbers is most inclusive, but the whole numbers is kind of its own. It's this tiny circle in the center of all the other stuff. Irrational is just an offshoot. Has no business with like some of the other numbers, but it is real. All right. Okay. So how we're actually going to practice this principle, we're going to work on number lines and making sure that we have good mental math. Mental math is huge. Yes, I know sometimes we have a hard time understanding what these numbers could be, but sometimes we have to be able to think these numbers like that really fast, right? So let me put some numbers on this number line, and we're going to place them in their appropriate locations. And we'll just use arrows. I think that's kind of good. I think negative 2 is pretty obvious. That goes right here, right? Negative 2 is pretty obvious. I'm just going to jump around a little bit. Where do you think 2.1 will go? Between what two whole numbers? Yeah, probably right there, right? 0 is pretty obvious. Okay, let's look at 13/4. 13/4 is slightly bigger than what number? Yeah, slightly more than 3. Okay, -10/3. It's negative, mind you. -10/3. Where do you think that's going to go? Well, first of all, how many times are we going to 10? But then a little more, right? Because it's 10, but it's negative. So it's -3 and a little bit to the left of -3. So it's like -3.33 repeating. I should actually draw the arrow over here. Sorry. There we go. But -10/3 is -3.33 repeating, right? Okay. Okay, now we get to the radicals. √3. I don't expect you to know √3. I mean, ultimately, you should know √3 what it is. But I'll be honest, like √7, I don't know. After I have to think a little hard about it. Like I know it's between two numbers, two whole numbers. So I don't know the decimals. But √3 I do know. But √3 is between 1 and 2. Why do you think I say that? Why would √3 be between 1 and 2? What's √4? What's √1? So naturally, wouldn't √3 be between √1 and √4, right? That makes sense. It's 1.7 something. I just know that. If you don't know, that's okay. But just know that it's between two whole numbers. And that's kind of good, especially in geometry. You guys remember doing the 30, 60, 90 triangles with √3, right? That's kind of good to know. How about √7? That's in between what two whole numbers? Between what two numbers would you say? It's bigger than √4, right? Is it less than √9? And what's √9? So it's between 2 and 3. Where it is exactly, I don't know. Is it more than 13/4? I think so. But that's okay if you don't know that. And then lastly, -√5. Where are you going to place that one? Between -3 and -2. Okay, cool. All right. So what we have you guys do right now on your own is list these in increasing order. Now we've had this discussion about how to rank the numbers and on the number line. Put them in increasing order. I'll give you guys just a moment to do that. You could check with someone you're sitting next to. After a minute, or less than a minute, shouldn't take that long. I'll share. I'm actually going to freeze my screen. I'll just do my screen right now. So start at the lowest and then keep going up. Okay, that's what I did. I just use the inequality symbol. If you put commas, that's fine too. I don't care. But just make sure you follow the instructions. So does that make sense? We're good? Okay. This next one, a lot of people are not really a fan of these problems because I don't think we do enough work with unit conversion or dealing with units. But it's good to do because just in life, you want to understand units really well. Give you a good example. I wound up baking banana nut muffins yesterday. My wife doesn't eat gluten or sugar, so she's very difficult to make food for. But I actually wound up making I used maple syrup instead of sugar. But I went online and said like 3/4 maple cup, sorry, 3/4 to 1 ratio between maple syrup and sugar, or 3/4 cup, 1 cup. So I had to do a conversion, right? Because if the recipe called for 1/2 cups of sugar, I got to figure out what does that mean in terms of how much maple syrup I need to use, right? So just something that's kind of interesting. Just in life, you got to do conversion, look stuff up online and convert it. So, of course, use a calculator if you need to. So let's go through these right now. And then we're going to move on to 1, 2, I think. I think the next one's on 1, 2. All right. And when it says look at 1-1 in a textbook, ignore that because this is the old textbook. We don't use it. We use CPM, and actually the CPM textbook's electronic, right? Unless you want to buy a hard copy. So hourly wage. So for example, did anyone work this summer or had like some of you guys worked or had a summer job? Do you guys get paid for it? Probably. Okay. So yeah, if you worked 5 hours, you know, like you showed up at the job at 8 o'clock, left at 1 o'clock, right? Even the lunch break got included, whatever. Or maybe you didn't take lunch. I don't know. And you got $60. You want to figure out what was your hourly salary, right? How'd you do that? You just divide the two. You do $60 divided by 5 hours, which is $12 per hour. There you go. It's that simple. A rate is a ratio. And what are you comparing? Money to time, right? How much time do you work? How much money you get, right? Next one. What does MPH stand for, guys? I'm sure some of you guys drive. Miles per hour. And per means division, right? So miles over hours. So that's the rate. 50 miles for every hour. So if you drive the car for 3 hours, right? Or 4 hours, in this case, 4 hours, you do this. Why would I multiply 50 by 4? Why not divide? What happens to the hours? Yeah, exactly. So you get 200 miles. So just use logic. I mean, if you want a formula, go for it. You guys might see that for D equals RT, where R is the rate and T is the time. But I don't like getting too heavy in the formulas. In fact, actually CPM, we try to extricate ourselves from a formulaic view. We really want to focus on understanding, right? So you want the units to cancel. Did anyone have chemistry last year? You guys remember grams and moles, right? I know. Okay. But that's what it is, right? It's just unit conversion. So that's what you're doing. Because you want like the grams to cancel, moles to cancel. So anyway. Okay, let's look at C now. This, as you can tell, this is dated. This is 2015. You guys remember Pokemon Go? Like it was like a human game. People tried to, yeah. My son loves Pokemon cards. Now he's getting that phase. But anyway, yeah, I remember this was like, gosh, like 9 years ago, people were all into this. But you need to walk 5 kilometers to hatch an egg when playing Pokemon Go. How many miles is 5 kilometers? What about 2 kilometers? What about 10 kilometers? Blah, blah, blah. So sometimes like you might see like people running a race, like if they run a 5K race, how many miles is that, right? Because that's what in this country we're special, right? We don't want to use kilometers. We think we're unique, so we have our own systems. We do miles, not like everyone does like kilograms or other stuff. We use pounds, but regardless, 5 kilometers. Here's how you convert it. You convert it like this. You want to do it like this because what happens to the kilometers units? They cancel exactly, right? Because if you do it the other way around, you don't get the cancellation then, right? Instead, you get something else. You get kilometers squared, or miles. You get something really, really weird. Because it should be less, right? Because you know, you get more kilometers to a mile, right? And I believe it's 3 point something. I've ran a couple 5Ks. Actually did one without stopping, but I'm not terribly fast. And just want to get better shape. So 3.1, we'll say 106 miles. Don't worry about the other conversions. You get the point. You know what you have to do. But yeah, that's how you do the conversion. Now let's look at D. Oh, I need more space. Okay. But any questions about C? We're good? Okay, let's keep moving. Now you need to be going under 20 kilometers per hour. What is that? Speed in miles per hour. What's speed in feet per second? That actually is a good thing to know. Because let's say you're in another country and you rent a car and you're driving. I think one time I did my undergrad at UC San Diego. I think I might mention that. And my friend wanted to go down to Mexico, and he was driving really fast. And I think the sign said like 80 or 90 kilometers per hour. So he was going actually 89 miles per hour. I'm like, dude, no, you gotta slow down. We're gonna be pulled over. Because he didn't do the conversion right. So anyway, how do you convert that to miles per hour? Here's what we do. Remember, it's 1.61 kilometers. And you don't have to worry about the time. So these go away. Know where that is. 12.422. Ah, miles per hour. Cool. What if I want to convert to feet per second? And that's kind of interesting because like if has anyone been watching the Olympics so far? Kind of. Yeah, I mean, by the way, that was a phenomenal opening ceremony. That was oh, and you guys know that Mr. Davidson's daughter is on the I heard she hurt her knee last night. Did anyone check that? Yeah, I was reading The Athletic and I was a little bit bummed to read that. So hopefully she's okay. Um, but the reason I bring up Olympics is that like there's like archery, there's like shooting, and sometimes they talk about feet per second, like someone the arrow, the bullet goes this fast, or what's another one? I think there's other like if someone throws a javelin or a shot put, I don't know, but um, sometimes things are in feet per second. It's hard for us to fathom what that means. Like something's moving at 300 feet per second. Is that fast? That slow? I don't know, right? So how do we do that conversion? Just understand it better. We'll do it right now. So I'm going to stick with this 12.422. I know I didn't leave myself no space, so hopefully you have space in your paper. So I'm going to roll with that one. That's 1 hour. So let's change the hours to seconds. How many minutes in an hour? 60. And how many seconds in a minute? 60 times 6 is 3,600. So I'll just go straight to seconds. 3,600 seconds. And then miles. 1 mile, you're told, is 5,280 feet. Okay. Now I just have to work that out. I'll do the math for you guys. I know you guys can do the computation, not to worry about it. It's 18.219 feet per second. So there we go. All right, last one. Where in class my sweet 16 birthday's coming up, convert 16 years to seconds. 16 years. How many days in a year, roughly? I mean, not roughly. 365. I mean, this is a leap year, but we'll say, non-leap year. So 1 year. And then 1 day is 24 hours. And 1 hour. Sorry, my handwriting sucks. I do need to get a stylus. Maybe one of these days I'll just all do tails. Try to order one today. Okay. But that's what happens. Because 16 years is a long time, right? Most of you guys are 16. So you've done a lot of living, right? So it's gonna be a lot of seconds. So you got to multiply by the number of days you've been alive, number of hours you've been alive, number of seconds you've been alive, right? So you just multiply all that out, and that's gonna be kind of crazy big. See here, times 24 times 3,600. That's 504 million. 576. Yeah. So there you go. And I'm 46 years old, so I'm 3 times that. So almost 3 times that. Anyway, So that's my second that person's been alive. And the key thing here, to not get confused, you always want these to cancel. It's a chain, like a chain reaction, right? And then you're stuck with what you want at the end. That's how you do dimensional analysis. So where do you put the 365? Go up top or up bottom? You know, the bottom, like, you get confused if you try to memorize. No, you want units to cancel. Remember, 16 years is like, that's a fraction of 6/1, right? The years goes up top. But then you want the next part to be below, and so forth. And it's actually, I think, a really good problem. I think it's yeah, these are okay. Yeah, like you see like number 7 and 8 on the problem sets, kind of do that. This one actually, let me just pull this one up really quickly. It's kind of a fun problem. Actually, it's real life. That was kind of fun to do in my head when I was traveling with my wife many years ago. Let's see here. Tests. And I'm sure you guys have been confronted with this if you've traveled internationally, which I've heard some people did. Yep, that's one. That's a good one. So yeah, we went to Morocco for our honeymoon and Spain as well. And we saw a gas station nearby, and we were just kind of curious if that's, especially, because oil's so expensive, gas is so expensive, and Morocco's not Middle Eastern, but it's North African, but they're still part of OPEC, I guess, or somewhat influenced by that. But yeah, that's per liter, because they use liters, and that's their currency unit. Back then it's $4, so it hasn't changed too much, I suppose. But anyway, that's kind of a fun problem, right? Like, if you know how many Moroccan dirhams are for the US dollar, and 3.8 liters a gallon, is that a good or bad deal? Is it cheaper or more expensive? It's kind of a fun problem, but we won't do that today. Maybe we'll do that later. But you can see like that would be kind of interesting, right? And we have to do some math. So anyway, kind of a real life situation that's kind of neat. Okay, we'll take a break in about 9 minutes. You guys doing okay? Yeah, we'll take a break in about 9 minutes. Let's finish off this page. Okay, I'm really kind of taking my sweet little time here, so I might have to speed things up a little bit. Or maybe I might have to taper. Maybe we don't do 1, 3 today. Maybe just do 1, 2. And that's fine. We can be adjustable here. Let me just paste this. Oh crap! Some of the stuff repeat. Oh my goodness. Oh my gosh. Okay, this makes me feel better. I got a little nervous here that some of these things. Sorry about that, guys. Some of these things repeated. Okay. Oh, okay. We're gonna be okay. We're gonna be good, guys. It's like, what the heck is going on here? All right. So yeah, something's repeated. I can't believe I did that. Wow. All right. But let's just finish off this page and we'll come back and do a break. So here, I don't care about the names of these properties. I actually forget commutative and associative sometimes. But what you do need to know is that this is true. You can reverse order of addition. 3 + 4, 4 + 3. Tomato, tomato, same thing, right? Or 3 × 4, 4 × 3, same thing, right? If you have parentheses and you just have addition going on, like no other things are happening, great. Move the parentheses around, who cares, right? It's all being added anyway. Likewise, multiplication, move around. Now, if you throw in some minuses or division symbols, then you can't do that, right? Then things will be different. Especially if you're punching in a calculator, right? It's calculator called order of operations. So we're kind of working our way towards order of operations, as you can tell. Identity property just means the number keeps its identity. If you add 0 to something, it stays the same. Or multiplying something by 1 stays the same. Inverse means you do the opposite. So if you add a number to its negative counterpart, it's 0. Or multiply something by its reciprocal, it's 1. It's kind of the opposite of the identity property. One more property. I think I know what this is. I should know this. I think it's distributive because I see in the examples below. Distributive means this. If you have like 2 times x plus y, that's just that. That's all. You distribute, right? You give it to each number inside. However, don't do this. And some people do this, and I think it's I'm not blaming you guys. I think it's just sometimes we misconstrue things because we don't really understand what I think we get so caught up, maybe anxiety kicks in and you get caught up in just similarities and you just want to just do this. Don't do this, please. I've seen some students do this in the past. But that's not true, right? So that's not true. Because that'd be 4xy. Really, all it's supposed to be is simply 2xy. That's all. Because think about it. What if I have 2 times 3 times 4? What's that going to equal, guys? 2 times 12, which is what? Yeah. But you can't do this. You can't do 2 times 3 times 2 times 4. Then that's a much different number. Now it's 48. You do not distribute with multiplication. Never, ever do that. It's got to be just with addition or subtraction. If it's subtraction, you can do the same thing. But never, ever do multiplication or division. It just goes to the rest of the numbers and that's it. That's something that I've seen. And I see, believe it or not, I've seen like people in calculus do it. Like I do a lot of test preparation for ST, ACT with other students. And I've seen them do it. I'm like, no, you can't do that. So anyway, simplify each expression, explain what property used. I don't care about the explain part. Just do it. You guys see what I just did? Put the 8 inside the first group, then -2 inside the second group. Combine like terms. And there you go. 6y minus 12. Next up, 5x squared, -10y, -6x squared, -8y. -x squared, -18y. So again, I just distributed. That's all I did. And then combine like terms. Okay, I see other people are taking a break right now. So let's just do a break because the next one gets into PEMDAS. And I think it's just, I don't want to leave that hanging. So it's 9:56. Let's come back at 10:06 and we'll do more of the notes and then we'll have some time to do some practice problems after that. 10 minutes. 10 minutes, yeah.
Hoffman, Becky Jones, Brady Grossman, Dylan Benz, Charlie Texter, me, Hunter Malenko, Lucas Manning. Dylan Benz was like, oh, and like 12. Like, I think so. Like, yeah, bro, he just didn't even bother. I think Devo saying from like man that Oh, I had Tyreek Hill too.
Oh, so you won.
I mean,
Tyreek,
no.
Devo, what do you got?
Well, Lucas Reddy, like, no, Beckett, that's it. Beckett, well, he did like, yeah. I think it's pretty good.
Who's the first overall pick these days in fantasy football? Yeah,
I'm second overall.
he did really well.
And this idiot is taking CeeDee Lamb first.
No,
He's holding out, right?
Could be good.
Is he holding out?
No idea.
Okay, I thought he was holding out, but
Honestly, I go with like Tyreek Hill.
I'm going CMC first rounder.
CMC is the most consistent.
The best player of all time.
Yeah, he's pretty. No, I mean the fact that like his career kind of took a little downturn with Carolina, and it all of a sudden was awesome. Yeah, I agree. I mean, he was the best offensive player. I mean, Tyreek Hill is more boom or bust. Like he might do like 5 catches for 6 yards, but sometimes he has like 10 catches for 200 yards and 2 touchdowns, right? Like that's. Yeah, I haven't really followed the fantasy landscape too much, but I know it's fun.
Don't the math teachers have like a fantasy?
The teachers do, yeah. They play for like so long now, and that's
Football amounts of money.
I think so, $20, so about half goes to charity.
Oh, that's. I think Mr. Davidson had like Mike Evans last year. I mean, he was all right.
Yeah, I just haven't really kept in touch with like the movement of players. 'Cause I know some players change teams.
You just gotta watch like one video and then you know exactly what.
Yeah, that's true. I'm a little worried about the Niners though, because usually history dictates that if you lose the Super Bowl, you tend to not do well the next.
Where's the Super Bowl being held?
I think Arizona.
Arizona.
And next year's here.
Yeah.
Yeah.
Season tickets.
Not a good at all.
So good.
Actually, I went up selling my seat license. I had a seat license for Levi's.
Oh, did you?
Oh, I'm selling it, yeah. 'Cause I don't go too many games anymore. But I'll probably go to one or two and just like splurge. I just think like this team is they might have another year or two, and then I think they'll take a dive after that. But John Lynch has done a great job with the team, so they're gonna have to pay Brock eventually.
No,
They're gonna have to pay Brock Purdy eventually.
Yeah, Brock Purdy looked like a Super Bowl quarterback, but he didn't.
The thing is that, except for Patrick Mahomes, who's just special, and Tom Brady, most teams, like once they pay their quarterback the money, they just don't do well because they can't commit the resources to other players.
the Niners are gonna win.
We don't want it all.
I know.
It's gonna happen this year.
You know what I think the biggest issue is? I think it's the coach, Kyle Shanahan. I just think he just overthinks. I mean, you got outcoached by Andy Reid again.
But like,
But the team was wrong.
that's true, but
They should have at least gone, they could have won it.
they should have won it.
You can't give Mahomes like all those opportunities that they tend to. But then again, Mahomes has won 3 of the last 4, or 3 of the last 5 Super Bowls, or something like that. Like,
He's like. It's so good.
They're wide receivers and I got them to do it.
But.
Brandon, I. Was in on that post Kittle.
Are you not a fan?
It's like semi Cowboys.
I'm not, you're a Niners fan?
Not really.
What team?
The Giants.
The Giants?
New York Giants.
Oh.
Oh.
I
Oh, team.
I was about to say I'm very sorry for New York Giants. Oh, so that's good, Giants. Yeah, that's good. I mean, they had their run. Yeah. That was fun. Those are fun times when they were playing. Yeah, I haven't been following baseball either. I know the Dodgers and Yankees are good, but yeah.
Yeah. What do you watch? Baseball?
I go to the game, I don't like watching.
Oh, that's right. I go to the.
Yeah, the games are fun.
Yeah.
The chickens are pretty. Not too expensive.
Football's really expensive.
4 or maybe 6 seats, new clubs for like a long time, and then we recently sold them. But we used to go every single game we used to go to, so it's so fun.
I
That was really fun.
actually, I guess I don't think I've gone. to-
Well, I gotta bring it back. Yeah, it's
so packed.
yeah.
Like it's like a special.
It's a whole day thing.
Yeah.
Yeah.
You can't just like go stop by for a few hours and.
Right.
It's
Well,
your whole day.
especially football. That's
Like bacon wrapped hot dog.
Oh my god.
Oh, yeah, I got them
Disgusting.
in New York. Like, I
They
just
look
got back
so.
they smell good. Yeah.
They smell good, but.
It's not good for you. Yeah.
I don't really trust like food vendors that like.
Yeah.
like, if you're-
Yeah.
Especially at Carter.
Yeah, because there's no health code. Yeah. Yeah, I'd no, because inside the stadium they actually have to adhere to a health code or a restaurant, right? I agree. Yeah.
Yeah.
I'm actually pretty excited to see the A's move to Sacramento, though. I think that's gonna be kind of next year. Yeah, because that's a nicer. It's a smaller state, but it's a more intimate, nicer place in Oakland.
I went to a Yankees. It's like not that busy, but like when everyone comes out, everyone just like gets back on the subway. So there's not like car traffic.
Right.
Everyone's just like. everyone's-
Chicago and Boston's the same way. Yeah.
Oh my god. Wow.
I think you're really uncomfortable.
Yeah, maybe you should have done that.
Who? Aiden.
Hey, oh my god, the government side.
Oh, dear. You don't know.
Wait.
Hey, what the hell? What is it like that?
No,
And you don't want it all up here?
no.
That's it, right here.
Lost guy in Hawaii.
One.
Oh,
Yeah,
lost
I
guy.
lost it.
He was stolen better than mine. I had like the bar kitty.
Yeah.
If the thing's going.
That's not good.
I don't know, she said she was not.
Yeah.
All right, guys, we're gonna get back. So you guys had a nice little break. So I think we will finish, we'll try to get to the end of 1-3, and we'll try to do some problem sets after that. So a little more lecturing, sorry. It should be less lecturing the future days. There'll be some videos I'll have you guys watch, in addition to doing problem sets. So we're in the middle of page 3, and we're talking about PEMDAS. Please excuse my dear Aunt Sally is a mnemonic you may have heard. So please, I'm not sure how that came about. Some of your probably parents probably know. So PEMDAS, that's a mnemonic to help you memorize it. But parentheses, exponents, multiplication, division, addition, subtraction, that's the order we follow. Multiplication, division are interchangeable actually, unless if you see a bunch of them, then you go left to right. Likewise, addition, subtraction. But for the most part, multiplication, division are interchangeable, addition, subtraction are interchangeable. And you want to be mindful like A and B, right? Like A is going to be 16, but B is going to be negative 16. The reason why is because that's -4 times -4, which is 16. This is -1 times 4 raised to the second power. So -1 times 4 times 4, now it's -16. So it's very subtle, but you want to be mindful about that. If the negative's inside the parentheses, you're following PEMDAS, right? Because PEMDAS dictates, I got to take care of the parentheses first, which is -4. I got to do that twice because you got to square it. Whereas here, what's inside the parentheses is a 4. The negative is actually third in that pecking order, right? So you got to take care of the 4 squared first, right? I got to take care of that first because that's higher. And then I do -1 afterwards. Okay, so you gotta be mindful about that. This is also, C is also -16. Because that's like saying -1 times 4 squared. And D is still -16. So even though there's different ways of writing it, they're very subtle. You gotta be mindful about the order of operations. So B, C, D are all -16, but A, of course, is 16. All right, now we're gonna actually kind of go deep with this. What's the first thing I should do for part A? You see a parentheses? Handle it. 1 plus 7 squared times 2, right? Okay, do you see an exponent? Yep, deal with it. 1 plus 49 times 2. Do you see multiplication? Yep, deal with that. 1 plus 98. And then lastly, get 99. Order of operations. Parentheses, exponent, multiply, then I add it, right? Go and try B on your own. See how that goes. I'll freeze my screen and do it, and then I'll reveal what I have afterwards. And we gotta do this without a calculator, mind you. Yes, sometimes 49 times 2 can be kind of tough to in your head. Sometimes we are okay with 4 function calculators because PEMDAS doesn't really help too much. But graphing calculator, unfortunately, would be a crutch, right? Because it does 4 of operations for you. So anyway, we'll work this one out. Give me a moment here. Okay, I hope you guys get this. 4. Good. Great. Awesome. Yeah, I took care of 5 times -1, but simultaneously I did 2 cubed as well. And then I subtracted and added after that. So, or did -3 times -5 then. Okay, C, we'll see together. Let me clear the screen and move it up. 4 minus, that's gonna be -1. Or actually, I'll just do this right now. Because that's what you're really doing, right? Minus -3 squared plus 5 plus 2 squared plus 6 times 9. Right? Because 3 squared is 9, 12 over 2 is 6. 6 minus 14 is 2. 4 minus 7 is -3. And just so we don't get confused, because law of negatives, right? -1 3 times. Let's just write that out. -1 is going to be multiplied 3 times. What happens when you multiply negative odd number of times? Is it negative or positive? Negative, right? Exactly right. So it's 4 minus -1 minus 9 plus 5 plus 4 plus 54. So by being very methodical and organized in our approach, we'll be okay. Math has to be that way, by the way, guys. Like, my desk is pretty freaking organized. Mr. Davidson, I mean, he's not here, but his is organized. Some of the religion teachers, when I have stuff for Mr. McDade, I'm like, dude, like, what the heck is wrong with your desk? Like, it drives me nuts. I actually organize for myself from where any of the, that's fine. They're great people, and their class is more interesting than this class. But anyway, bottom line is you gotta be organized. You gotta think this way, right? That's how you do math. That's just how I live my life. So that's 5. That's gonna be -4 and plus 58. I'm just like adding, subtracting pairs of these numbers. And that should be 59, I think. You can always plug in a calculator too, and it should give you the right answer. In fact, actually, let me pull up I have a computer version of I think it's that folder, math department. Yeah, there we go. It's actually right when we came back from the pandemic that year. All right. So if I were to actually punch all that in, 4 minus parentheses -1 cube minus parentheses, or you go Desmos. And of course you could punch it in wrong too. That's totally possible. There we go. So the calculator does order of operations, all it knows. So we know we did it right. We're not gonna do number 9 because that just messed up, and I'm not gonna try to figure out what the symbols are supposed to be. So let's cross that off. I think you guys get that idea. Like, this is trying to show you something that's done wrong. You have to fix a mistake, but the formatting just messed up. I should have been mindful about that. Number 8's still a PEMDAS situation. You just got to plug in for the variable and work it out. Pretty easy, right? You should get 62. Wait, is that right? 48. Yeah, 62, right. Okay. I don't know what the heck I did. So there's a bunch of random stuff. Just need, do we have enough time to get to this? Well, let's see how far we get, because I do want, I say at 10:30, I'll kind of stop the notes and have you guys do problem sets afterwards. So I want you guys working on problems today. So let's go to, what's the section 1.3, solve linear equations. An equation has an equal sign, an expression, no equal sign. It's really that simple. The problem is that what we just did right now, I'm just gonna move my screen a little bit. Like this right here is not an equation, guys. We'll call an equation. So we have to be very mindful of the term. We can't blur it anymore. Like that's not, I will correct you if you're in my class. That's not an equation, that's an expression. And you're plugging in or evaluating. You don't solve expressions, you evaluate expressions. Equations we solve because you're trying to see what the variable equals. Here we evaluate, we want to know what the expression could be. So that's really the big difference. Equations have equal signs, expressions do not. So these are equations. Part A is an equation. You gotta solve it. I'm just gonna kind of just jump into it because you guys have had algebra 1 already. But you know, there are certain techniques you could use. What can I do first? What do you guys think I should do first, Ray? How about that one? Where should that one go? Subtract the, yeah, exactly. That's a good idea. And then what's X connected to at this point now? So I should get rid of that because doesn't that mean multiplied X? Now this is a part that again, totally not your fault. That I blame the pandemic for. Maybe you guys are fine with this, but fractions I've noticed over the last 2 or 3 years has not been the greatest for my pre-calculus or algebra 2 students, mainly because you tend to learn fractions in middle school, right? Or 4th or 5th grade. And what happened 4 years ago? We were in pandemic mode, right? Like at this time 4 years ago, we were told school was gonna be closed, and then it was just all crazy, right? So if you're like a rising 10th grade, you were a rising 6th grade 4 years ago. Or if you're a rising junior, you're a rising 7th grade. This is when you're supposed to be doing fractions, right? So don't worry, it's the same thing as a whole number. You're going to divide by -3/5. But if you think about it, that's like saying 3/1. Right? You got to flip the fraction you're dividing by. And those cancel. Or you can just do -15/3, which is -5. So that's the answer. So that's how I'd approach it. Some people do this. We're at this point here. They'll multiply both sides by 5 first to get that, and then divide by -3 afterwards. That's fine too. You still get the same thing. Some people do this. They'll multiply both sides by the reciprocal of the fraction. That's fine too. That could also work. So yeah, that could work as well. Now for B, it gets a little tricky because then you have multiple fractions, right? When that happens, I like to find what's called the LCD, or the least common denominator, which is least common multiple among the denominators. Where are your denominators here? 5 and 4. 20, yes, good. Because 4 and 5 both go into 20. Yes, good. Here's what I would do. Because 4 and 5 both go into 20, right? Of course, you could do something bigger if you wanted to, but why? Sometimes what happens, like, don't write this down, but like if you have like 4 and 6, what's the least common multiple of 4 and 6? 12. You can say 24, but then you're gonna have to simplify afterwards, right? Some people just multiply the two numbers together and say that's the LCD. It's a common denominator, it's not the least. It's just more work for yourself afterwards. But yeah, so here's what I'm gonna do. I'm going to multiply both the left side and both the right side by 20. This is the technique that CPM preaches, and I'm fully on board with it. This is actually the way I've taught it for 20 years. You want to get rid of the fractions right away, because fractions are really going to be a nuisance. Yes, I want you guys to be good with fractions, but let's be honest, math is a lot easier without fractions, right? So even when I get annoyed, when I bake something that has to do with like a fraction of something, I get annoyed by that, right? So if we can avoid fractions, we should. So I'm multiplying the left side by 20, the right side by 20. And what's happening, it becomes this. I'm going to do it in a drawn out way, but I'm doing it for your benefit. You distribute that 20 like this. I know it's kind of lame what I'm doing. Actually, let's do this times 1. I'm making 20 a fraction, 20 over 1. I know it's kind of lame, but I'm doing it because I want you to see that the 20 distributes to both of these, right? You're doing 20 over 1 times -3 over 5. How do you multiply a fraction? Do you guys remember? You multiply numerators and denominators, or can you cross cancel? If you can, don't cross cancel when it was an equal sign, only on the times you can do it. What's that going to be? It'd be 20 times -3 over 5. What does that become? What's 20 over 5? Just 4, and then 4 times -3. -12, right? Exactly. So that's -12x plus 20x. So you made the problem so much easier for yourself. Equals 5x plus 20. Now the problem's way more manageable, right? 8x equals 5x plus 20. 3x equals 20. X equals 20/3. So yeah, that's what I would do. Instead of combine the fractions, I would just get rid of the fractions right away. That'd be my approach. So what you're doing, I think it says so up above. Yeah, multiply both sides by the LCD. It says it right here. Multiply both sides by the LCD. You literally do that. I think I'll just do one word problem, and then we'll stop there. And then we'll just pick the rest of his notes on well, I'll do a video on the rest of this. I'll do the video probably between, I have a meeting at 11 o'clock, so probably around 12-ish I'll do it, and I'll post it to Schoology. So if you're gonna look to do work, wait till, because some of you guys are doing an English class afterwards. Some of you guys have more stuff now, just this. Okay, cool. If you have, anyway, but by 1 o'clock I'll have everything posted to Schoology. So anyhow, one other thing you could do too for this, you go to Desmos, and especially for those who are doing SAT, if you graph both left side and right side, yikes. Did I do that correctly? Yeah, and you see where they touch, and that is 20/3. So you totally could get away with it, and this is great when we start talking about equation of lines. We're gonna revisit this kind of problem. If you have two lines, which those are, right? That is a line. That actually becomes 2 -2 x. Sorry, no, 2 x. And that's, the slope is 1/4, 1. So this is a great connection to graphical stuff, which we'll do later in the week. Where they touch is the answer. So you totally can, I mean, yes, on a test, we're not gonna let you do this. On the SAT, you do have that option, just so you know. College Board knows this. You just do it, get the answer. So something to think about. Okay. One word problem. Let's just talk about it and then we'll stop there. Let's see, be sure to define any variables. Actually, do I want to do the word problems? Hold on a sec. Let me look at the, you know what? Let's hold off the word problems. So let's start doing some practice now. So we'll finish off this, because there's like several parts. So I think you kind of want to do all these together. So we'll do the word problems tomorrow. I'll do a video on it. So what I'm gonna ask you guys to do is watch a video and say, go to these pages in the notes and watch a video on this stuff. And I'll talk a little about 1.4 and 1.5 as well. And then we'll have a lecture tomorrow, but it'll be a shorter lecture and it'll be more problems we'll work on. But for today, here's what I want you guys to do for the next half hour. So on this homework packet, some of you guys have a color. No, some of you guys have a color, some don't, because the color toner went out when I was doing this last week. But for section 1.1, I want you to do all problems except number 11. So number 1 to 10. So we'll hold off on the challenge problems till later. Maybe after we go through more of these problems, we can do the challenge problems together as a review. In section 1.2, and feel free to work with each other. I'll come around and help you guys out. 1 to 10 again. We'll do 11, 12 another time. Maybe that tomorrow. That might be good. It's gonna be the homework packet looks like this right here. Cynthia, right? Or yeah, so like she has a color one, but some of you guys don't. She's special. No. And then section no, you are special. Anyway, in the section 1.3. Number 1 through 9. So if you're fast, you could probably get all this done today. Maybe, I don't know, before 11 o'clock. You can get most. You can put a pretty big dent in it. And again, I'm not going to be collecting the homework, but you really want to do this, right? I mean, this is for your benefit. Because also, like, I will take a look at yours, because I will do an assessment by the end of next week. And it'll show whether you've been doing the work or not, right? So you want to do this for yourself. So anyway, that's what we'll do. I'm gonna go and stop the video, and I'll come around and help you guys out. You have a question, Clark, right? Yeah, go ahead. Oh yeah, 100%. Yeah, go for it. Yeah. And the answers you guys have, the extra packet, I gave you guys the answers too. You guys have the answer. So this should be pretty low tech. You don't need a device. Am I right? Yeah. What was that? Sorry. We're doing this for the whole class. Is that right? Oh, you're missing last day. Oh, that's fine. Okay. Yeah, no worry. Yeah, that's fine. No, thank you. Yeah, no problem. I will forget, but don't worry. I'll know it. Yeah. All right.